This is a short introduction to Ansible Engine. In this short presentation, we're going to cover off what Ansible Core Engine is, what it can be used for, and finally how it works. This will provide a basic understanding in order to get started with Ansible. Red Hat offers a single product SKU called Ansible Automation Platform for supported Ansible offerings. You can think of this as multiple layers of functionality as seen in the diagram. The SKU provides an automation capability, a platform, Ansible Tower, from which you can control execution and various SaaS and supplementary services on top. For this session, we're going to cover the Create layer. This is where we use Ansible Core Engine to provide us with a basic unit of automation. In a minute, we'll cover off the basics of writing automation and getting started. But first, let's look at the main features and benefits of using Ansible. Ansible was designed from inception to be simple, and that still holds true today. You don't need any special coding or language skills. We simply write something called playbooks, which are YAML-indented plain English sequentially followed text. There's no compilation. Playbooks are copied over to the target nodes, run, and then deleted. Ansible is very quick to learn and makes you productive in no time at all. Common use cases for automation are things like systems provisioning, patching and configuration, but at the heart of all this are modules, which you can think of as snippets of code pre-written for you to do the very discrete tasks that you want. These tasks might be, say, adding a user into AD, provisioning a number of servers in AWS, doing young updates, you name it. Ansible probably has a module for it. More about modules in a minute, as they are a fundamental part of Ansible and one of the main reasons it remains a market leader today. Finally, Ansible is agentless. Out of the box, we use OpenSSH by default to connect to our target automation nodes, but we can also use the likes of WinRM for connecting to Windows nodes and other connection types for things like network devices where SSH may not be available. Not having agents to worry about is especially important at scale, so Ansible is more efficient and secure out of the box. One of the beautiful things with Ansible is its depth and breadth. We only have to learn the basics once, and then we can use the same automation methodology across all these things. No learning a new tool or doing things differently just because the target platform is different. Modules are probably the main reason we can do this, so we'll talk a little more about them now. A module is a piece of code that does something consistently and repeatedly for us. There are thousands of modules now and growing by the day. Modules are provided by Red Hat, partners, the community, and customers. This extraordinary growth shows no signs of abating, as you can see by the numbers in the slide. When you install Ansible, modules get installed as well. They're all fully documented, getting put through a rigorous QA process before being accepted. This documentation is available through the CLI, or online. They include snippets of playbooks which you can cut and paste to get started with. This gets you in the automation game really quickly. Now let's quickly walk through how Ansible works. In the following few slides, we'll break down this diagram to explain in a little more detail. We already know that we write playbooks, which are indented YAML formatted plain English. Tasks are executed sequentially top to bottom as we define them in the playbook. This gives us complete control over execution. This is often important as we need to do prerequisite tasks before we can stand up what we really want. For instance, to stand up a cloud server, we first need a regional resource group, virtual storage and network interfaces, security groups, etc. Only then can we instantiate an actual server. We can define these steps within the playbook to give us complete control over formation. Perhaps we may also need to apply configuration or patch a server after installing an application. We may need to take the application server out of the load balancer pool in order to do this, then smoke test the changes and reintroduce back into the pool in a particular order. Again, we can do this inside our playbooks. Within our playbooks, we'll use these mighty modules. These have been written in many languages, but tend to be Python or PowerShell based for Windows nodes. Modules simply use key value pairs to get us in a desired state. Most modules are what we call idempotent. We should be able to call a module and it will only make changes on the server where necessary. I like to call this write once, run many. You should also seek out a module for your task where possible. If there isn't one, there is a get out jail card, which are the shell and command modules, allowing us to run arbitrary commands on target nodes. but note that these modules are not idempotent, so we'll always make changes. When we have our playbooks ready to do something, we need to tell them what to automate against. This is called the inventory. Inventory can be static, like the example in this slide. The sections in square brackets, for example web or DB, are groups. Using groups, we can automate against a collection of targets at once. We can also use dynamic inventories. These are very popular in cloud environments. Before running automation, we can make a dynamic inventory call to get the latest information. In this way, we can target only those servers powered on, or perhaps in a particular region, or with a specific service tag. If we want to target all our inventory, there is a special all group. By using this inside our playbook, we can target everything. We can also nest groups. For instance, the DC group on the right contains two other groups, core and access. Ansible supports a hierarchy of variables. We can have group-wide ones or assign them down to individual hosts, which will override the group ones. We need to be careful what we store in variables, especially if we plan to put our inventory under source code management. Ansible Automation Platform addresses this with a number of inbuilt services, or you can use third-party integrations. Time for a real example. Here we have a playbook which will install, configure and start an Apache service. The three dashes at the top of the file indicate that it's a YAML file. The host line is our inventory to target. This could be an individual host or a group of thousands. The become directive defines our privilege escalation method. In this case, use sudo, which is required for package installs on our servers. Within a play, we have tasks. Here we have 3 tasks. We want to do things in a particular order, as that makes the most sense. Always use name lines to inform people what's been done. We'll see this in the output when the playbook is run. Within the tasks, we call those modules to do the work for us. In this example, the yum module is called to install the HTTPD package. The other modules being used here are the template module to copy local files over to a remote node and the service module in order to start HTTPD. You can see we pass in key value pairs to these modules to get to the state we desire. We use simple color coding by default to highlight the output. Green indicates the task executed successfully but didn't have to make any changes. Yellow indicates that we did have to make a change. And finally, red means something went wrong. Using these, it makes it easier to see what's going on. We use the Ansible-playbook command to run our automation tasks via our playbook. Here we can clearly see what's being run. We're targeting a web group of 3 servers, web 1, 2, and 3, from our inventory. By default, Ansible will gather facts about each server. These facts can be used in our automation tasks. For instance, we might want to know the OS in order to use a specific package manager, or perhaps make a database configuration change based on the amount of RAM. If we don't need these facts, we can disable their gathering, making execution a little faster. You can clearly see the tasks being run in order. In this case, they are all yellow, which indicates to me that this is the first time we've run this automation, as we've had to make changes. If we were to run this again, it should all be green, as the idempotency will ensure that we only make changes that are necessary. We're able to run this playbook over and over again to get to the same declarative state. When we want to make our playbook automation more reusable, we can start thinking about something called roles. This is nothing more than a directory structure where we break things down into smaller chunks to make them even more manageable and repeatable. There is no science to this, but as a general rule of thumb is that if your playbook is starting to get very long, maybe over 100 lines, then start breaking it down into roles. On the right-hand side, you can see how we call a role within a playbook. You can see it's much cleaner and readable. You don't need to write roles, but if you find yourself rewriting a lot of common automation tasks, then this is a candidate for a role. Others can then reuse what you've created rather than reinventing the wheel. That concludes this short introduction to Ansible.